Hello, this is our presentation for the final project for CS584. We have worked as a two members on this project, myself Shubham and my other teammate.
Srinivasa.
Yeah. So we have worked on the problem statement related to predicting the promotion of the employees, and we have also investigated the incorporated bias in the dataset that we have used. The background and the motivation behind working on this project was that HR analytics is revolutionizing the way human resources department operate, leading to higher efficiency and better results overall. Human resources has been using analytics for years. However, the collection, processing, and analysis of data has been largely manual, and given the nature of human resources, dynamics, and HR KPIs, the approach has been concerning HR. So, in order to save time and money, we are introducing ML-based model, which also reduces human bias in the process. But this can introduce the model bias, which we try to investigate using different mathematical formulations. So the goal to work on this project was like to first we are classifying the geometric data and then investigating the incorporated bias. So these are the different classification models that we have used, like logistic regression, SVM, and random forest. So going with the data sets, like we have these are the attributes that we are training, and we are targeting the promotion attribute. So the logistic regression gave us the accuracy up to 78. We also tried SVM, and the random forest gave the highest accuracy till 93 because it has the best models and that are uncorrelated and outperforms the individual model. So ROC curve for random forest is 0.83. So going forward to handling the bias, we have decided to go with random forest. Now Srinivasa will take over the presentation.
So to understand the correlation between the attributes, we used correlation matrix. We performed two experiments on this data set. We performed anti-classification and classification parity. In anti-classification, we removed protected attributes like gender and age. We also tried removing the other two attributes, region and department, which may also involve bias in the data set. The result for this experiment gave an increase on accuracy from 0.993 to 0.94. The other experiment is the classification parity. We calculated FNR and FPR with the unprotected and protected attributes, with removing protected attributes and without protecting unprotected attributes. With protected attributes in the data set, the false negative rate came up to 0.064 and false positive rate came up to 0.074. Without protected attributes, the false negative rate is 0.075 and false positive rate is 0.072. The observations were the top five important attributes within the protected attributes data set gave length of the service, education, number of trainings, recruitment channel, and age. Without protected attributes, the top five features in the random forest were length of service, number of trainings, recruitment channel, previous year rating, average training score. With the protected attributes, age was involving the classification, and so this is the bias we observed. The results of the graph, the results in the graph are there is a very minute change in F1 score with the protected attributes and without protected attributes. The change is very minute here. The conclusions we came up to are the random forest is the best classifier among the classifiers which we used. Removing the protected attributes during the training reduced bias, but in our case, it was very minute. The accuracy and F1 score, the increase in accuracy and F1 score were very little. The data processing and increasing accuracy might not be a good approach to get insights about the bias, but it will obviously increase the overall accuracy of classification. As we see, there is no marginal change in F1 score and accuracy. Hence, we can say that our data set doesn't have any considerable bias. Thank you.